Hi guys, so it's been a while since I posted. I was studying for this exact test, and today we're going to be doing AMC10A's number 14 and AMC12A's number 12. So here we have all the roots of the polynomial, and this is the polynomial, are positive integers possibly repeated. What is the value of b? So when I got this problem, I figured it out based on Vieta's formulas, and that's what we're going to be using today. Okay, so here's an example. This polynomial is to the power of 5. So there are 5 roots. They are labeled. Basically, Vieta's formulas gives us the relationship between the roots and the coefficients. So x1 plus x2 plus x3 plus x4 plus x5. This is the sum of them individually, and this equals negative b over a. Okay. Let me just highlight that. Okay. So, the next one is, okay. Okay. x1 times x2 plus x1 times x3 plus x1 times x4 plus x1 times x5 plus x2 times x3. It's basically taking sets of 2 from those 5 roots. So, yeah. It's every root times another root except for itself, and these added together would equal c over a. So keep in mind that those are all coefficients. Okay, next up. x1 times x2 times x3 plus x1 times x2 times x4. These are sets of 3 now instead of 2 like before. I'm not going to write all of them. Okay, plus x3 times x4 times x5 equals negative d over a, and that's also a coefficient. Okay. So it's just a pattern of taking sets of one more number. Okay, next, x1 times x2 times x3 times x4 plus x1 times x2 times x3 x5 plus x2 times x3 times x4 times x5. Obviously, there's more, but I'm not going to write all of them. That equals e over a. So the last one is, I'm not going to write it there. Okay. Okay, so the last one is the product of all 5 of them together. That would equal negative f over a. So as you can see, the negative and positive are alternating, but it always starts with negative. So we can use Vieta's formulas to tackle this problem. Let's just call the 6 roots a, b, c, d, e, and f. Not to be mistaken with the uppercase coefficients. Those are different. So we can see that 2 of the coefficients are already given to us. So negative 10 and 16. And we can use those 2 numbers to find the relationships between the roots. So a plus c plus d plus e plus f equals negative b over a, or in other words 10, because it's negative 10 over 1 because there's no coefficient for z to the power of 6. Now the product of a, b, c, d, e, and f would equal, let's just see, okay, 16. It's positive 16 over 1. Okay, so at this point, we can just do some guessing and checking. As you can see in the problem, it says that the positive integers or the roots can be repeated. So, yeah, we can keep that in mind. And we know that 16 equals 2 to the power of 4. So, let's assume that maybe there's 4 2's, and then because there's 6 roots, 2 1's. And those add up to 10, and their product is 16. So let's just call those roots a, b, c, d, and f, e, and f. Those are all different. So the coefficient b, that's what we're looking for, equals negative the quantity of the products of these subsets of 3. And so if we calculate that in the end, we're going to get negative 88, which is A in the test. Thank you.